In this video, we're going to finish up the electrochem section of this 2018 Chemistry 30 diploma. We're on question 20. There's 3 more questions that have to do with electrochemistry, and then I'm going to stop the video, and then the next one will be on organic chemistry. Which row identifies one characteristic of a voltaic cell and one characteristic of an electrolytic cell? A voltaic cell, I guess we can work our way row across. So in a voltaic cell, the cell potential is less than 0. In an electrolytic cell, it's a spontaneous reaction. In a voltaic cell, you convert chemical energy to electrical energy. And an electrolytic cell moves anions towards the cathode. In a voltaic cell, you move electrons towards the anode. In an electrolytic cell, you reduce the strongest oxidizing agent at the anode. And in a voltaic cell, you require a type of salt bridge, and an electrolytic cell requires an external power source. All right, let's move through each of these statements. A voltaic cell, we looked at one in the previous question that would have been in a previous video. It was the one with the zinc battery, zinc and manganese 4 oxide. This is an example of a voltaic cell, and I said earlier in that question that the reason that we know it's a voltaic cell is because we have a positive cell potential difference, which indicates that we have a spontaneous reaction, which also indicates that we are harnessing electrical energy from chemical energy. And so we look through our statements again. This would be true of an electrolytic cell, not a voltaic cell. So this is an incorrect statement. And then this is actually also an incorrect statement, where an electrolytic cell is a non-spontaneous reaction. If you didn't remember the difference between voltaic cell and electrolytic cell, these statements are opposites. If you flipped these two, then it would be true. A voltaic cell converts chemical energy to electrical energy. That's true. In an electrolytic cell, you move anions towards the cathode. That's false in both cells. In both a voltaic cell and an electrolytic cell, anions go to the anode, and cations go to the cathode. That's true in both types of electrochemical cells. C moves electrons towards the anode. That's false for both types. In both cells, electrons go anode to cathode. And then you reduce the strongest oxidizing agent at the anode. So the strongest oxidizing agent is reduced, but it will be reduced at the cathode. The cathode is where reduction takes place. So actually both of these statements are false. A voltaic cell does require a type of salt bridge. An electrolytic cell does require an external power source. This is a definitions question. Do you know the difference between a voltaic cell and an electrolytic cell? And can you pick out things that are true here? A couple statements here, like if you flipped A, then that would be true. But then B and C have things that are false for all sorts of electrochemical cells. So it's important to remember anions go to the anode, cations go to the cathode. Electrons always flow anode to cathode. Reduction always occurs at the cathode, and oxidation always occurs at the anode. The reason why you have a salt bridge in a voltaic cell is you need to separate the reactants so that the reaction doesn't occur within the actual electrolyte. You want to be able to force the electrons to move through a wire so that you can hook them up to some sort of load and get some sort of useful electrical energy out of it. Electrolytic cell requires an external power source because you are providing electrical energy. You're converting electrical energy to chemical energy. It's the opposite of this statement, so that you are reducing basically a weaker oxidizing agent than the reducing agent. Moving down. The silver from sunken treasure is gradually transformed to silver sulfide by exposure to marine chemosynthetic bacteria. The silver sulfide forms a layer on the surface of an object. The layer of silver sulfide can be removed by electrolysis in a dilute solution of sodium hydroxide or NaOH. All right, something I want to point out here. If we are removing something by electrolysis, it means that we have an electrolytic cell. Which, if we have an electrolytic cell, it means that our oxidizing agent is below our reducing agent here. The half reaction that the hydroxide ion undergoes in this electrolysis is what? Well, let's take a look at what we have present here. What we'd have present here is we would have, first of all, I'm just going to list our species present. That's what I'm going to do. We have silver sulfide, we have water, and we have a hydroxide, and we also have sodium. Let's take a look at our redox table in the data booklet and then figure out what are our oxidizing agents and what are our reducing agents. So remember, oxidizing agents are going to be listed in the left side of the half reaction arrows. So if you look we can start at the top and work our way down. There's a lot of information here, but you can find silver sulfide right here. This is an oxidizing agent. You can also find water. I'll zoom in a little bit. Water by itself can also act as an oxidizing agent. And you can find sodium. So all three of those are oxidizing agents. So I'm going to write underneath them that these are all our oxidizing agents. But of those three, our strongest oxidizing agent is our silver sulfide because it is the highest on the left. So this is our strongest oxidizing agent, which means that our reduction half reaction will happen with this. Now, hydroxide as an anion doesn't occur on our oxidizing agent side. In fact, lots of our oxidizing agents, lots of our strongest ones, are in acidic environments. This is a basic environment. And you'll see that we have hydroxide occur in multiple locations on our basic side. So we need to see which one would actually match what's going on here. So this hydroxide here, this is our strongest reducing agent with hydroxide. This is not present. We don't have sulfite and hydroxide. We don't have hydrogen gas and hydroxide. We don't have nitrogen monoxide and hydroxide. We do just have hydroxide by itself. This would be our reducing agent. And if we're comparing the two, here's our reducing agent, and here is our oxidizing agent. So our oxidizing agent is below our reducing agent, but we were expecting that because this is an electrolytic cell, which means that the reducing agent that's going to be reacting at our anode, our half reaction is this half reaction. But because it's a reducing agent, it is going to do our oxidation half reaction. This is the reaction C that you would find in the table. But this is a reduction half reaction. This is our reducing agent, so we're going to have to flip the reaction to show the oxidation half reaction, which has electrons on the product side. B and D are not the correct answers because hydrogen gas is not present anywhere in this description of our electrolysis. Next question. Which of the following metals will act spontaneously as reducing agents with silver iodide but not with silver sulfide? Remember that the word spontaneously here means that our oxidizing agent is going to be above our reducing agent. Now, our two oxidizing agents that we're comparing here are silver sulfide and silver iodide. We want a metal where silver iodide and silver sulfide, the metal lands as a reducing agent between silver iodide and silver sulfide. So it would be spontaneous with silver iodide, but it would be non-spontaneous with silver sulfide because it appears in the table below this reducing agent. This is going to be our metal. So this is, it says here that we're going to use the information to answer questions 21 and 22, but this is all just based on the redox table. Go to your redox table, and you're going to find silver iodide is right here. It is higher than silver sulfide. So we're looking for metals that occur between those two. We have nickel, cobalt, cadmium, chromium 2+, iron. I think it's asking for solid metals, though. It just says metals. We don't give us any ions anyway. So we're looking for two things that appear in the middle there. And the two that appear in the middle there are nickel and cobalt. Mercury and copper are above both of them, so they would react spontaneously with neither. Copper is up here, and mercury is even further up. So it would react spontaneously with neither. Chromium and aluminum are below silver sulfide. So chromium is here, and aluminum is down here. It would react spontaneously with both, so that's not the right answer. Nickel and cobalt are between the two. Gold would react with neither, and magnesium would react with both. So the metals that are between the two are nickel and cobalt. And that's where I'm going to stop the video for this one.